Welcome to ChemSkills Podcast Suite, podcast number 2, entitled Assigning Oxidation Numbers. In this presentation, I will explain to you the purpose of oxidation numbers and how oxidation numbers are assigned. Let's begin with the question, what are oxidation numbers? Oxidation numbers are an arbitrary number that describes the ownership status of an atom's electrons. In other words, it explains what's happened to an atom's electrons during a reaction or in a particular molecule. Let's take water as an example. The water molecule, as you can see, contains 2 hydrogen atoms and 1 oxygen atom. The electrons shown here as red and black squares are shown halfway between the hydrogen and the oxygen. The reality is that these electrons are not actually shared equally and are not found midway between the hydrogen and oxygen nucleus. In fact, the higher electronegativity of oxygen results in the bonded electrons being drawn closer to the oxygen. So in other words, each hydrogen atom has lost some control, or as I would describe, ownership of its electrons. The molecule resembles this one shown at the bottom of the page, where the electrons are actually closer to the oxygen. So this means that hydrogen is given an oxidation number of +1, and that's because it's lost some control of one of its electrons. It's one and only electron, the electron that's moved towards the oxygen because of oxygen's higher electronegativity. Oxygen, on the other hand, is given an oxidation number of -2, and that's because it's gained some control of 2 electrons. It's gained an electron from each of the 2 hydrogen atoms in the water molecule. Oxidation numbers are written in a very specific way. They are shown for each atom and only for the single atom, and they are written above the symbol in the formula. So in this example for water, you can see that hydrogen's oxidation number, which is +1, is written directly above the hydrogen symbol in the water molecule, and the oxidation number that's written is the number for a single hydrogen atom. The oxidation number for oxygen is -2, and that's shown above the oxygen, the symbol for the element in the molecule water. Notice that the sign of the oxidation number is written before the number, and plus means that the atom has lost electrons, minus means that the atom has gained electrons. Let's look at another example, H2SO4, sulfuric acid. When we look at the structural formula for sulfuric acid, a reasonably complex formula, we can look for the electrons in the molecule. Now, for simplicity, I've only shown the sulfur electrons here in this diagram indicated in little black squares. Now, sulfur's in group 6, so it has 6 outer shell electrons. And because in the molecule sulfuric acid, sulfur is bonded to oxygen, oxygen having a higher electronegativity will draw sulfur's electrons towards it, thereby each oxygen gaining a greater control of sulfur's electrons. In effect, sulfur has lost partial control or lost some ownership of 6 of its electrons. Now, this means that the oxidation number for sulfur would have to be +6. Now, plus because it's lost control of the electrons, and 6 because there are 6 electrons that have been drawn away from it in this particular molecule. Now, the electrons for hydrogen aren't shown, but it's the exact situation as we previously discussed with water. So hydrogen would lose its electrons to oxygen. So the hydrogens in this molecule have each lost 1 electron to the oxygens that they're bonded to. And the oxygens in this molecule, therefore, would each have gained 2 electrons. So hydrogen would be given an oxidation number of +1, and oxygen would be given an oxidation number of -2, because as you can see in the structure here, this oxygen atom has gained 2 electrons, the 2 from the sulfur, 1 in each of these bonds in the double bond there. And the way that it's written in the sulfuric acid molecule H2SO4, the oxidation number for hydrogen +1 is written above the symbol for hydrogen. The oxidation number for sulfur +6 is written above the symbol for sulfur. And the oxidation number for oxygen -2 is written above the symbol for oxygen. And once again, notice that the signs of each of the numbers are written before the number, and that the oxidation number is the number for each single atom in the formula. So there are 4 oxygens in this molecule, each of them having an oxidation number of -2. There are 2 hydrogens in this molecule, each of them having an oxidation number of +1. So in summary, oxidation numbers allow us to determine the status of an atom's electrons. If an atom has lost electrons, then the sign of the oxidation number is +1. If an atom has gained electrons, then the sign of the oxidation number is -. The numbers are written above the atomic symbol for the element in the formula, and the numbers that are written are only for the single atom, only for one atom. The best way of determining the oxidation numbers is to examine the structure of the substance. So you would need to draw the structural formula, and then having done that, you can determine where the electrons have gone. And in each case, they'll move towards the more electronegative of the 2 elements that are involved in bonding. Now this is time consuming, and many students don't like drawing structural formulae. So in the next podcast, I'll show you a shortcut method for assigning oxidation numbers. Thank you for listening.